Hey folks, welcome back. Factoring and applications, lesson 4. Factoring trinomials in the form of blah, whatever that says. That says a f of x squared plus b f of x plus c, where f of x is actually some kind of other expression, okay, or other thing. Now, the workbook, whoever published this workbook, at this point introduces substituting something else into the expression to make it a little bit simpler to read. So, for example, x to the fourth plus 5x squared plus 6, okay, with some substitution ideas, which I'll go through, we can make that look like a squared plus 5a plus 6. Now this, looking significantly easier to factor, because that's what we've been used to, we should be able to factor that, but then at the end we have to replace what we pulled out. Now that'll make sense as I go through some examples, but I'm not a fan of it being introduced here with this style of question, but later on when the questions get more difficult, it is significantly easier to say, hey, you know what? Let's make a minus 3 equal to, or x minus 3 equal to just a capital A. Okay, so this would be 7a squared minus 4a minus 3. This significantly easier to factor than this. Okay, but in the end, once we have our factors, we have to remember, well, we started by doing this replacement. So in the end, we have to replace it back in and simplify. Okay, so that'll make more sense later. So I'm going to do a couple of these examples up here at the beginning. I'm going to do a couple of these examples presented the way the book does, and then I'll talk to you about how just using simple logic might be a bit of a better way to do it for these simpler types of questions. Although they look complex, they're simpler. Okay. So essentially, what they're saying is that if we tried to factor x squared, or sorry, x to the fourth plus 5x squared plus 6, if we tried to factor that, that power of 4 and that power of 2 doesn't look normal to us, but we can make it look normal if we do just a little bit of manipulation. So what we do is we manipulate this x to the fourth 5x squared plus 6 into this x squared squared, which is essentially x to the fourth plus 5x squared plus 6. Right? So we just change it around a little bit. Now you can see that this x squared and this x squared are the same. So if we replaced that with something else, in this case, the book says, well, you know what, let's replace that with a capital A. That expression would now look like this, a squared plus 5a plus 6, which is nice and simple to factor. So then you would factor that, and it factors to a plus 2, a plus 3, right? A plus 2, a plus 3. But because we did this substitution, we have to put it back in. So now this turns into these, where we change that a back to the x squared. Okay, so that's essentially what's kind of happening. Now, like I said, I'm not a fan of these style of questions in doing this replacement setup or let statement. But later on, you'll see when it becomes important. And I'll show both ways. There's two ways you can do it. Like I said, one a little bit more logical, the other one using this substitution or let statement thing. So let's look at some examples. Maybe it'll make a little bit more sense. So we have a to the fourth minus 5a squared minus 14. So I don't want to use the letter a this time because a is already in there. So I'm going to use, let's use x, okay? Let's say, because this can be rewritten as a squared minus 5a squared minus 14. And if I say, hey, you know what? At this point, let's say x is equal to a squared. Now, by substitution, I can write x squared minus 5x minus 14, just by substituting x in for the a squareds. Now, this is easier to factor. Well, it looks easier to factor, so we factor it. So we look for two numbers that multiply together to give, I need a pen, multiply together to give negative 14. Those same two numbers add together to give negative 5. And we have choices of 1 and 14, or 2 and 7. So it's got to be 2 and 7, where 7 is negative. 2 minus 7. 2 minus 7. See, that works. So now this is factor by inspection because this is a 1 out here. I don't have to worry about doing decomposition, so I can go straight to my brackets. This square rooted, right? So this is going to be x, and then minus 7 plus 2. Except now we have to remember, well, we did this replacement, right? So I have to put that back in. So I simply replace my x now with every a squared, or every x with an a squared. So I get a squared plus 2, a squared minus 7. Done. Now, like I said, you don't really need this substitution theory or work with this type of question, because I can just factor that normally if I use a little bit of logic, right? So let's say, so I've got a to the power of 4 minus 5a squared minus 14. Now, this is factorable. We know it's factorable because we just did it. The issue is, well, what do I do? What do I do? Because this is a 4 and this is a 2, okay? As long as this exponent here is even, then all you have to do when you get to your binomial brackets is make sure you cut that exponent in half. A squared, cut it in half, because you're square rooting this to get to this thing anyway. So square root of a to the 4th is a squared. If it was a to the 6th, then the square root of a to the 6th would be a cubed. So you half that exponent. And then this, as long as this one is half of this one, then you're set and you're good to go. So they have to be that multiple of each other. And then I factor by inspection. This is going to be plus 2 minus 7. Right? So really, there's not a lot of difference to it. The question just looks a little bit more complicated. But with this substitution setup or theory or idea, let statement idea almost, when you get to more complicated factoring questions, it may sometimes be a better thing to use. Okay? I'm not saying to never use it, but I'm saying in some instances like these questions, I probably wouldn't use it. Okay, so I'll do one more using that, and then I'll just do another one using logic. How's that? So question B, x to the 4th plus 4x squared minus 5. So this x to the 4th can be written as x squared. And if I put this in a bracket, then you can see I can substitute x squared. If I say let a equal x squared, then now I have a squared plus 4a minus 5. And I simply factor by inspection. Two numbers that multiply together to give negative 5, add together to give 4. That's going to be positive 5 minus 1. Yep, positive 5 minus 1. So this is factor by inspection. There's no number out in front of this a squared, so I can go straight to my brackets, square rooting this first term, that's a, and then I'm going to have plus 5 minus 1. But remember, this is where I started. I substituted this out, so now I have to put it back in. So everywhere there's a capital A, I put in x squared, plus 5, x squared minus 1. Right? Question C. X to the 6th minus 9x cubed plus 14. So There's no number out in front here. So I'm going to do this one using that logic idea I was talking about. So I'm looking for two numbers that multiply together to give 14. Those same two numbers add together to give -9. So it's got to be -2, -7. So I can factor by inspection. So I know that the second part of my binomial brackets are -2 and -7. Then to find the front part, or the first part, I simply square root x to the 6th, or cut that 6 in half. So x cubed, x cubed. Another way to think about it is, if you have this relationship where this is half of the other, this is what's going to be here. That kind of term with that power, right? So far, so good. Oh, I did notice something though. We have to jump back to B, because the question actually says factor completely, right? So we have to look at this. Remember, at the end of every factoring question, you should always be double checking. Does it factor any further? Does this factor any further? The only way a binomial could factor further is if it was a difference of squares, correct? So is this a perfect square? Yes. Is this a perfect square? No. So this doesn't factor. Is this a perfect square? Yes. Is this a perfect square? No. So this doesn't factor. So this is done. But if we look at B, this can't be difference of squares because that's a plus. So that one doesn't factor. But if we look at the second bracket, that's a perfect square. That gives me x. That's a perfect square. That's going to give me 1. Separated by a minus, this is difference of squares. So really, this x squared minus 1 is going to factor to x plus 1, x minus 1. Don't forget, we had this first factor here too, x squared plus 5. Okay, so for some of these questions that have larger exponents in them, chances are that something later in the question is going to factor again. So you have to make sure that you're doing that last double check. So if we flip the page, flipping the page, the question just goes into some more complicated factoring. Okay? It's the same idea. You can use the let statement to do substitution, or you could just use logic and work from there. Like I said, I'm not a fan of doing the substitution with simple questions or simpler questions like this, so I'm just going to use logic for these examples on this page. But you'll see, I believe on the next page, the top of the next page is where we're going to actually see where we would use that substitution idea. Okay. So factor completely, it says. So that's a hint. Factor completely. That's a bit of a hint saying, hey, you know what? Maybe you're going to have to factor again. So be careful, right? Be careful. 4x to the 4th minus 5x squared minus 6. First of all, do your half-half check. Is this 2 half of 4? Yes. So this is going to work. Okay. Well, the idea is going to work. Whether or not it's factorable, we don't know yet. So I look for two numbers that multiply together to give -24. Those same two numbers add together to give -5. My choices are 1 and 24, 2 and 12, 3 and 8. Oh, that looks like 3 and 8, 4 and 6 to get -5. So if it's -8, so if it's +3 and -8, that gives me -24. +3, -8 gives me -5 if I add them together. Okay, so this is factor by decomposition, so I need to split this term up. Okay, 4x squared, nope, 4x to the 4th plus 3x squared minus 5x squared minus 6. Remember, these terms have to be exactly the same. They're like terms to get back to this original. So it's going to be x squared, okay? Factoring by decomposition, my next step is a bracket, or not a bracket, a t. There's my t. Greatest common factor of 4x to the 4th and 3x squared is going to be x squared. If I factor out an x squared from 4x to the 4th, I get 4x squared. If I factor x squared from 3x squared, I get 3. The next side, 5x. Well, that's not 5, is it? That shouldn't be a 5, that should be an 8. -8x squared minus 6. It's got to be a negative value and probably a 2. So that's going to give me 4x squared minus 3 plus 3 because it's minus divided by a minus. Those are the same. 4x plus 3, x squared minus 2. Double check to make sure that nothing else, sorry, this should be a squared. Nothing else is going to factor again. This is not a difference of squares because it's not subtraction. This is not a difference of squares because this 2 is not a perfect square. So this is factored. This is done. Okay. Question B. Question B, 2a squared b squared minus 31ab plus 99. So a squared b squared, power 1. This is going to work just fine. Okay, so I'm looking for two numbers that multiply together to give. 99 times 2 is 198. And they're going to, multiply to give. And they're going to add together to give negative 31. Those two numbers after some searching is going to be 9 and 22. Negative 9, negative 22. Negative 9, negative 22. So I'm going to decompose. 2a squared b squared minus 9ab minus 22. That's a 2. Yeah, 22ab plus 99. Draw your t for your t factor or factor by grouping. Greatest common factor of 2a squared b minus 9ab is going to be ab. That's going to give me 2ab minus 9. And then over here, it's negative, so that's going to be a negative 22 and 99, 11. That'll give me 2ab minus 9. Same. 2ab minus 9. AB minus 11. Okay. No need for any substitution or let statement, right? Because you can logically figure it out. You can just use your factor by decomposition and some of your exponent knowledge and work it out. Check to make sure these don't factor further. Well, they don't because there's no squareds in them or any other powers. So we're done. And of course, neither of these questions or any question so far had a greatest common factor at the beginning, right? So that's always our first step. Factor completely the expression 8x to the fourth plus 10x squared minus 3. So I'm going to look for two numbers that multiply together to give. Negative 24. Same two numbers are going to add together to give. Plus 10. 2 and 12. Negative 2, positive 12. Negative 2, positive 12 gives me negative 24. Negative 2 plus positive 12 gives me positive 10. There we go. So I'm going to decompose my middle term. 8x to the fourth plus, minus 2x squared plus 10x squared minus 3. Draw your t. Greatest common factor of 8x to the fourth and 2x squared is going to be 2x squared. That'll leave me 4x squared minus 1. Greatest common factor of that shouldn't be a 10. That's twice I've done that. That should be a 12. 12. Greatest common factor of 12x squared and 3 is going to be 3. That's going to give me 4x squared minus 1. So my factors are 4x squared minus 1, 2x squared plus 3. Do my last double check again, making sure that nothing is going to factor further. This is not a difference of squares because there's a plus sign. This 4x squared is a perfect square. 1 is a perfect square separated by a minus. So this is difference of squares. Straight to my brackets. Square root of 4x squared is 2x. Square root of 1 is 1. 1's plus, 1's minus. Don't forget, we had that other factor as well. Okay, that's fully factored. Over the page. Now we actually get to see, okay, maybe this one looks a little more complicated than it really needs to be, right? So we've got sine and cosine values in there. Given that sine x all squared is written as sine squared x and cos x all squared is written as cos squared x, factor those two questions. So let's start with A. First, we're going to go 6 bracket sine x squared minus 7 bracket sine x plus 2. Now you can see that if we replace sine x with something, it might make this question easier to read. So let's say that sine x is going to get replaced with a big capital A. This is now 6a squared minus 7a plus 2. Now we can factor that. Two numbers that multiply together to give 12, add together to give -7, -3, -4. And hopefully some of these factors are coming to you that fast. Okay, so 6a squared minus 3a minus 4a plus 2. Draw your T. Greatest common factor of 6a squared and 3a is 3a. That'll leave me with 2a minus 1. Greatest common factor of minus 4a and 2, so it's going to be -2. That's going to give me 2a minus 1. Look, they're the same. 2a minus 1 and 3a minus 2. But remember, we started this question by saying sine x is actually equal to a. So now I have to go 2 sine x minus 1, 3 sine x minus 2. And you're done. Okay, so now you can see that that's a better use of this let statement idea, let a equal sine x squared, than it was in the previous questions, because this one's a little tougher to see. Same with example 5 when we get there. And there's one extra step at the end in example 5. So if we do question B, 4 cos squared x plus 11 cos x minus 3. So this is also the same as 4 cos x squared plus 11 cos x minus 3. And if we say, let's say cos x is equal to, let's use a different letter, big capital B. This is now 4b squared plus 11b minus 3. And now that's factorable. Well, we hope it's factorable. I'll look for two numbers that multiply together to give -12. Those same two numbers add together to give 11, positive 12, -1, positive 12, -1. Decompose 4b squared plus 12b minus b minus 3. Draw your T, factor by grouping. Greatest common factor of 4b squared and 12b is 4b. Leaves me with b plus 3. Greatest common factor of minus b and minus 3 is at least -1, b plus 3. Those are the same. b plus 3, 4b minus 1 comes from those parts. Remember, we started this question with the let statement, a substitution, so we have to substitute cos x back in. Cos x plus 3, 4 cos x minus 1. And that is factored. Okay, moving on to example 5. Example 5. At the end of some of these factoring questions, there is one last little step. So we're always doing that last step of looking for other factors. There may also be a last step of simplifying what's in the brackets. Oh, I actually don't have these done on my page. Okay, so here we go. So 7 times x minus 3 squared minus 4 times x minus 3 minus 3. So you can see that these x minus 3s, these x minus 3s here, okay, they're the same. So really, I could do a let statement saying, well, let's make big capital A equal to x minus 3, which means I could change this to 7a squared minus 4a minus 3. Then you'd factor. Two numbers that multiply together to give negative 21. Those same two numbers are going to add together to give negative 4. I think that's going to be negative 7 and positive 3. That looks like it works to me. Okay, so I'm going to decompose 7a squared minus 7a plus 3a minus 3. T for my factor by grouping gives me 7a, a minus 1 plus 3, a minus 1. Those are the same. A minus 1 is a factor. 7a plus 3 is my other factor coming from there. Because I substituted x minus 3, so I have to do this. So this is where it gets a little bit tricky. There's my starting bracket, x minus 3 minus 1. I always put these back in brackets because there's some bombing that might have to happen. So 7 bracket x minus 3 plus 3, and you can see it right there with that 7, right? So now we don't like to have brackets within brackets. So we need to, there's a 1 in front of this bracket. We're going to bomb that in to get rid of the brackets and combine and simplify. And we're going to do the same with the 7 over here. So this is going to be x minus 3 minus 1. This is going to be 7x minus 21 plus 3. X minus 4. 7x minus 18. Factored. Okay, now that's about the trickiest that you might see at this point. I would like you to do this question. Pause your video, do this question, and what are we going to do? Pause the video, do this question, then you can come back to the video. I will have it written out, but I'm not going to walk through it step by step. Okay. So you pause the video, you did this question. Here is your solution. And there is your worked solution. So substituting a for x plus 4, finding your two numbers, factor by decomposition, resubstitute in x plus 4, and simplify both sets of brackets. Okay. That takes us to the end of lesson 4. I'll do a couple of examples at the beginning of whatever class we do this, if need be. Otherwise, check Scholantis calendar for what questions need to be worked on or completed. And we will see you next time.